Hi, good evening, good morning, good afternoon, whichever time zone you're on. So let's have a wee look. Going back to integration. So I think this is probably part two. I'm sure it is. If you look up the top left hand corner, that's what it says. So we're just going to have a wee look at an area question here. So looks like I've got some kind of quadratic function in the graph. It's not quite parabolic, it's the best I could do. So the thing is here, what we're doing is we're actually looking at the curve, but we're looking that as one boundary and the x-axis as the other. So this makes things a wee bit easier. When we're looking at x-axis, that's one of our boundaries. It does make things a wee bit easier, and you'll see that as things progress. Okay, so that's um, the kind of area we're looking at. Under 3x take away 2 take away x squared, and above the x-axis, um, which has equation actually x equals 0. So that's the way we're going to approach it. As in the previous lesson, we approach this between area between the curve I'll just put it in there, top minus bottom in relation to x or whatever it is. So we're going from A to B. For us here, A to B, we can see what A to B is. They've actually given it to us as 1 over 2. So the top curve looks like that there, and the bottom curve looks like the x-axis. So let's go for that. So that looks like the top curve there. 3x to go with 2 to go with x squared, and the bottom curve is the y-axis. So and just to make things crystal clear, the what x-axis has equation because it's a horizontal line. It's y equals 0. That's a definite there. So that's why it does make it a wee bit easier. Right, so it's top take away bottom, and they've already given you the limits of integration. And the limits of integration, just so you know, furthest point left in terms of x, and from furthest point right in terms of x. So that's where we get there. So that's why those are the limits of integration. Right, okay. And again, it's going to be top minus bottom curve. So top curve, that's 3x take away 2 take away x squared. And like we said earlier, y equals 0. That is definitely the bottom boundary there. Okay, right, so that means it just looks like we're integrating under the given function there. That's what it looks like. But we are really subtracting 0 from this so that it agrees with the normal routine of top minus bottom. Okay, let's go. So I think so So we're going from 1 to 2, 3x take away 2, take away x squared, and take away 0, that doesn't matter. So let's start integrating here. We've already given us the bounds is 1 and 2. So let's just highlight that. So from the picture, they have given you the that's fine, 1 and 2. So that's why we do have 1 and 2 here. If they didn't give them, we would use for other techniques that we had used previously to go and actually find these things called the limits of integration. So we're going to integrate in relation to x with respect to x. That's what that means. We're going to go and integrate top curve take away bottom curve. So it'll be top curve take away 0. So that's why we'll just get that there. Okay, let's start integrating. So to integrate that, that's why I get the power of 1 there. So if we integrate that, that goes up by 2 and divide by 2 here. That's 2 times x to the power of 0. So when you integrate that, it just becomes 2x. Here, add 1 and divide by the power there. So that's quite nice. So 2 add 1 is 3 and divide by 3. Okay, so that's we should have that there once we integrate. Yep, okay. Yeah, that looks fine. Okay, let's box up and take our limits. And usually they take the limits and put them there. Doesn't matter. Right. We're now going to take these limits and take them anywhere you get x. You put it in, so it'll be your first one. You put x in there, and then we do exactly the same thing with the value of x on the second one. So we've got the upper value of x and a lower value for x. That's fine. So here it's going to happen. Right. So upper value for x, lower value for x. Let's go and take things, put them in. Okay, so I'm just cut and paste here. That's exactly what I had there. Took that there, and I've just taken x away and put in a wee bracket. And put in my upper limit, or I shall. And then I've got the exact same thing again, and I'm going to subtract between two. I just want to emphasise that that's a big subtract sign, okay. Big subtract sign there. So upper limit 2, lower limit 1, put them in, start working things out. Just take your time on this part. Either use your brain, use a calculator, whatever's best. Do the same second part and then start tidying up and see where we get. Looks like we're getting 1/6. So the good thing is it's a positive answer. So area, like volumes, they should always be positive or 0 at a minimum. And so we've got 1/6. Just leave it like that. So that will do today. Right. So I think that looks good. There. 1/6. That will do. So that was a nice wee question there. Yep. Right. Okay, just come back here, folks. Sorry. Yep, that's fine. Right. Okay. Oh, this is what happens when you're working live. You need to go back. Right, let's go now. So 1/6 units squared, whatever it was, that's nothing. So I just need to emphasize that. Okay, because we're dealing with some kind of area here, so we just need to have it as units squared. Right. But like I said, you could be dealing with volumes of revolution, something like that there, where you might be taking some kind of curve and rotating that about some axis, so it's called that the x-axis. So you could be coming up with some kind of volume there, and if you're coming up with a volume there, just to let you know, that would be the integral of pi y squared in relation to whatever the variable was. It would be dx. Right. So, and the units here would be cube. Right, but in this unit, up until now, we're just dealing with areas. Okay. But, but, but like I've shown you there, we can just take it on to volumes. Just going from 2 dimensions up to 3 dimensions, and that is not a problem for us one little bit, not a problem, because we can cope. Right. Okay. So that was just a little bit of background information for you. Maybe you need to know that in case you're progressing following this stuff. So let's move on. Going to, can we fit in another question? I think we can fit in another question. Right, okay, let's go and fit one in. So again, two functions here. One, right, so we're working 2 dimensions here. This one here that looks like a parabola, and this one here looks linear. So x squared take away 1, that looks something like that. Y equals 3, that looks something like that. So we are working out this area kind of in here. That's what we're doing. I'm sure I'll get a better picture in a few seconds or so. So that's what we're doing here. X squared take 1 and y equals 3. So, and it's the area bounded by these curves. Okay, so a few things we need to know here. Left and right limits of the region bounded, but I'm going to refer to them as A and B. And the hatched area in red, or whatever colour that appears to you as, that's what we're going to go for. So the little formula we're going to go for there is the area from A to B of top minus bottom. So I'm just giving you a wee bit of time here to think about what's involved here. Aye, it's all well and good for me. So A and B that's the extreme left and right of the region. That's where we get these from. Okay, that's where A and B are from. Extreme left and right of the boundaries of the area, and the kind of horizontal. Limits. That's well, that's actually they are limits. And top and bottom. Well, hopefully you can see top and bottom are the bounds. So that's actually the lower bound. So you need to bear that in mind. And y equals 3. That's that bound here. Okay. And we're looking for everything enclosed within there. Right, let's move on. So top bound minus bottom bound in relation to the values of A and B. So A and B, that's what we call the limits of integration. So let's go and find them. So we get top, we know top bound, bottom bound, and we know that actually the curves x squared take away 1 and y equals 3. So x squared take away 1, y equals 3. Let them equal to each other. See, when I say, just for so we don't confuse each other, when I say let them equal each other, because we know y is equal to y, that's fine. So that's why we make y here and y here equal to each other. So x squared take away 1 is equal to 3, because here the line meets the curve, and here they've got coordinates, an x and a y here and an x and a y here. So the thing is, the height is the same here. Why? That is why they are equal to each other, because the heights are the same. Okay. Too much going on here. Too much going on. So they are the same. That's why we're making x squared take away 1. We are making that equal to 3. Right. Oh, I've lost the plot here. Sorry, folks. Yes, Tommy's lost the plot. I'm not rewinding this. I'm not rewinding this. Right. So x squared 1 equals 3. Let's do that. Sorry, folks. This is what happens when you're recording stuff in your house for your benefit, not for my benefit. Your benefit. So x squared to go 1 equals 3. Pre-continue. Yes, you can sit and chat amongst yourself. So we're going to solve that. X squared equals to 4. How are you going to solve that? You've got various methods. Take square root. Yeah. If you take square root, you need to remember, because we're not dealing with the lengths here. So that's two possibilities, positive or negative 4. So the answer is going to be positive negative 2. Or you could approach that in a different means by recognizing that as the difference of two squares. That's fine. Separate and solve. Okay, and you would get the same answer there. So you would have x equals negative 2, or x equals, I'll just put that in as positive 2. Even though you wouldn't write it as positive 2, but it's just to emphasize it. So that they are going to be the limits of it integration. So the smaller one goes here, and the bigger one goes here. So that's what would be happening. Okay, in the next part. Right. So A to B, that's the negative 2, positive, top minus bottom, that's the two curves, yeah? Top minus bottom, remember it was y was equal to 3. Okay, that's where we got that, and y equals x squared, take away 1. So I've just put in that negative 1 there, just to emphasise, because that's going to be multiplying that and that there. So I've just put that in to emphasise it. So y equals 3, that's just a horizontal line, so that's y equals 3, and your x squared, take away 1, that's that part there. So that's the region we're interested in there, and it's bounded from there to there, from negative 2 to 2. So that's what's going on here, and we're summing that up. We're adding up all the wee areas, and that's what that means there, and that's what that means. So we're summing up all the wee areas here. What does it mean? What does it mean summing up all the wee areas? Well, all these wee areas here, it's just like wee rectangles. That's what we're doing here. We're just summing them all up, and hopefully we come up with a big area, a finite area. Right, that's what we're doing here, folks. And eventually, all these wee rectangles, we'll smooth them out. We'll just smooth them all out. Come up with a nice curvy thing. Right. Okay, let's get rid of these brackets here. So with 3 take away x squared plus 1, hopefully. So we've got that there. And the 3 and the plus 1, they'll interact. So 3, I'll get 3 and I'll get plus 1. So that should give you 4. The 3 and the plus 1 should give us 4. And we'll still be taking away x squared. Yeah, that should be okay. So, yep, apologies. 4 take away x squared, okay. Right, so let's integrate this. So 4 on its own, when you integrate 4, you know, 4 on its own equals to 4x, and x cubed, well, x goes up to 3, and divided by 3, and we got a wee minus between them. So we should have that in the next line. Okay. Yep, there we have it. But please note that we've moved on our limits of integration. Yep. And you go, make sure you get a positive upper limit and your lower limit to negative 2. So we're going to be putting these in here. So I've just copied and pasted the expression I had before. I've just get rid of the x's and copied and pasted again. And between the two of them, please note, always taking board here, and like to emphasize, it's always a negative there. That's got nothing to do with that there, because that's just to do with that. Okay, nothing to do with that. We all subtract here. Right. Okay, let's go and put in my limits here. So we get 2 up, upstairs. So that upper limit is going in there, and going in there, and the lower limit is going in there, and going in there in the second bracket. Right, so We've done that. That's fine. That looks okay. Right, so for some reason this keeps going back and forward. Right, so I've put the limits in and evaluating. So 4 times 2 is 8, 2 cubed is 8, over 3, just leave it like that there. So we're just doing a wee bit of arithmetic here. Hopefully you can cope with that. So let's sort 8 take away 8 over 3, that's like 24 over 3, take away 8 over 3, whatever. 16 over 3, take away, that's going to give you a wee plus there. That's what I mean with the wee plus, wee negative, it's going to give us a plus. So 16, 16, 32 over 3, I think. And I think that's us there. Yay! That's our answer. So I think we're finished. And I think I'm going to leave it there. Yeah, I'm going to leave it there. Just get rid of that. Just get rid of that. But we'll keep the 32 over 3 in a wee box here. So, yep, I'm done, folks. So let's go and call it a wrap.